Question 11. What is ionic equation for ionic half equation that occur at cathode when molten lead to bromide? Whenever we have a molten substance, it means it does not contain water. So molten lead to bromide, it contains lead ion, which is +2, and it contains bromide ion. Molten means like there's no water present, so there is no H and OH ion. So the positive ions attracted towards cathode and the negative ions are attracted towards anode. So when the lead ion will move there towards the cathode, so Pb is +2. So the lead is +2. So when the lead ion is attracted towards the cathode, it will take 2 electrons and it will turn into lead atom. And for bromide, which is -1, it will lose 1 electron and turn into bromine atom. But because bromine is a non-metal cannot exist as an atom except for group 8. So when 2 bromide ions are there, they will lose 2 electron and it will form bromine molecule. So the question is, when we do electrolysis, which ion will move towards, like what will the equation for cathode? So at cathode, lead should be there. So it cannot be B or C because in that bromine is there, bromide ion or bromine. So when we check the option, lead ion is attracted towards the cathode, it will gain electron and it turn into lead atom. In question 12, the complete combustion of a propane is exothermic. Whenever you have an exothermic reactions, the reactants have high energy and the product should have low energy. So this is wrong because this is for endothermic. This is also wrong. So either C can be an answer or B. Then we have to, like in the beginning, we should have reactant and then form a product. So reactant should form a product. Here, what is wrong here? That they write product first and then the reactants at the last. So that's why this is not correct. So D is the right answer because the reaction, as it is mentioned, the reaction is exothermic. Remember, whenever the reaction is exothermic, reactants have high energy and the product will have low energy. So A and B, why it is wrong? Because it is given for endothermic reaction. Then why C is wrong? Because for C, they write product first and then they write the reactant. But it should be reactant first and then they form the product. In question 13, which equation represents a reaction that takes place in a fuel cell? Basically, what happened in a fuel cell or a hydrogen fuel cell, that hydrogen combined with oxygen in a fuel cell, and as a result, it produced water, H2O. And fuel cell also generated electricity. So in a fuel cell, we don't have carbon react with oxygen, give carbon dioxide or carbon burn. It's not in a fuel cell. In a fuel cell, we use hydrogen as a fuel. So when hydrogen combined with the oxygen, it formed water. So B is the right answer. Why C and D? Because C and D are burning of the fossil fuel like natural gas as well as the propane. That is why it is incorrect. So remember, in a fuel cell, we use hydrogen fuel. Hydrogen combined with oxygen give off water. In question 14, when sulfur is heated, it undergo a dash change as it melts. Remember, whenever the substance changes the state, we call that as a physical. Like example, we have a sulfur in a solid state. We supply the heat energy and that causes sulfur to melt. Sulfur convert into molten or a liquid state. So what we call this change, there is no new substance formed. So whenever no new substance formed, we call that as a physical change. But when sulfur when it is further heating sulfur to undergo dash change from sulfur dioxide. So how sulfur dioxide is formed? So this sulfur reacted with oxygen and it will form sulfur dioxide. So whenever new substance is formed, what we call this change, we call that as a chemical change. So in option 1, there should be physical, and option 2, there will be chemical. So C is the right answer. Question 15. 4 statements about the effect of increasing a temperature on reaction are shown. Which statements are correct? The activation energy become lower. This is totally wrong. Why? Because activation energy can only be changed by using a catalyst. If you use a catalyst, then only activation energy can be changed. So any option which is having 1 is totally wrong. So A and B are totally incorrect. Then when we increase the temperature, the particle move faster. Yes, that is true. When we increase the temperature, there will be more collision between the reacting particles per second. Number of collision every second will also increase. And there will be more collision which have energy more than activation. So activation energy does not change, but the proportion of the particle which are having energy more than activation energy, that increases. Like particle will have high energy. So statement 2, 3, and 4 are correct. So that's why C is the right answer. So changing a temperature will cause the particle to move faster, will cause particles to collide often, and will increase the energy of the particles which have, or proportion of particles which have energy more than activation energy. But remember, activation energy can only be lowered by using a catalyst. This is an example of a redox reaction. So here, whenever element state, the oxidation number is 0. Here, element state oxidation number is 0. So when we identify the changes, zinc 0 becomes zinc plus 2. So if there's an increase in oxidation number, what we call that change as oxidation. And if this change is oxidation, the substance which oxidize or oxidation happen, that is known as the reducing agent. So basically, zinc atom is a reducing agent. When we check for copper, copper is plus 2, it becomes copper 0. Plus 2 becomes 0. So that is reduction. And if it is a reduction for a substance which reduction happened, that is an oxidizing agent. So copper ion here, the reducing agent, is a zinc is a reducing agent, and copper ion is an oxidizing agent. So when we check the statements, which statements are correct? Zinc is oxidizing agent. That is wrong. Zinc is not an oxidizing agent. So A and B are totally wrong. Zinc is reducing agent and it oxidized. Look, if it is a reducing agent, it should reduce the other. So zinc is a reducing agent and it reduces the copper, not oxidize the copper. Till this point, it is correct. But this statement is wrong because it does not oxidize copper. Copper is not oxidized. Copper is reduce or reduction happen for copper. So D is the right statement that zinc is a reducing agent and it reduces the copper or decreases the charge on the copper. In question 17, which statement about the reaction in equilibrium is correct? Equilibrium, for a reversible reaction, what happened? Like example, if I have say 3 grams of the reactant and I have 7 grams of a product, what is the meaning of equilibrium? Equilibrium means when if 1 gram of a reactant is forming a product, at the same time 1 gram of a product will form back the reactant. So equilibrium means that the rate of the forward reaction and the backward reactions are same, and there is no change in the concentration. So which statement is explaining the equilibrium? Both forward and backward reaction proceed at the same rate. That is true. Like the speed, if 1 gram per second of a reactant form a product, at the same time 1 gram per second of a product will decompose and form back reactant. Neither forward nor backward reaction proceed or occur. That is totally wrong. The amount of the product present no longer affected by change in temperature or pressure. That is wrong, because reversible reactions, the temperature, pressure, and changing the concentration all affects the amount of product. An amount of product present only affected by pressure, that is also wrong. Remember, for a reversible reaction, the amount of the product can be affected by concentration of reactant and product, or addition of reaction or reactant or product. It can be affected by temperature, and it can be affected by pressure as well. So all these three factors can affect the position of equilibrium. So A is the right answer, which shows that the rate of forward and rate of backward reactions are same or occur at a same speed. Element X forms an oxide that neutralizes sulfuric acid. So whenever, remember, there are types of oxides. We can have basic oxide. We can have acidic oxide. So first thing, like you can simplify like metal oxide and non-metal oxide. Like metals can combine with oxygen, non-metals can also combine with oxygen. If a metal combined with oxygen, if there's a combination of a metal with oxygen, then there are two possibilities. It might form a basic oxide. It might form an amphoteric oxide. What is the difference between basic and amphoteric oxide? Basic oxide can only react with acid only. And amphoteric oxide can react with both acid and alkali. It can react with acid, it can react with alkali. If it is a non-metal oxide, non-metal oxides can be divided into two categories. Either it can be an acidic non-metal oxide, or it might be a neutral non-metal oxide. If it is an acidic non-metal oxide, it can react with base only. And if it is a neutral, so there is no reaction. It can neither react with acid nor with an alkali. So when we check the options, element X form an oxide that neutralize the acid. So it means it react with acid only. So which oxide can react with acid when you check? So you will find that basic oxides are the oxide which can react with acid. So it means this should be a basic oxide. And basic oxides are metal oxide. So what should be this element? This element should be a metal. And what kind of oxide is this? That is a basic oxide. So B is the right answer. In question 19, copper 2 sulfate is prepared by adding an excess of copper oxide with a dilute to warm dilute sulfuric acid. Which purification methods are used to obtain pure solid copper sulfate from the mixture? Because what we did, like example, we have a copper oxide is there, copper oxide is solid. So we have sulfuric acid, H2SO4. So originally this solution is sulfuric acid, which is H2SO4. Now what we are doing to this solution, we are adding copper oxide. Copper oxide is solid. We are adding it. As a result, what happened? We add until copper oxide is in excess. Excess means like more than enough, like we have too much copper oxide. So when the reaction occurs, when copper oxide react with sulfuric acid, this solution will turn into copper sulfate, which contain copper ion and sulfate ion, because copper oxide mixed with sulfuric acid give copper sulfate. So solution will be there as a salt solution of copper sulfate, and there will be unreacted copper oxide. Some of the copper, as we add in excess, excess means like we add more than enough. So there is a copper oxide which does not react. And now solution acid is completely used up and the solution turned into copper sulfate. We want to take out this salt. So, but before taking out the salt, we have to remove this unreacted copper oxide. So how to remove this unreacted copper oxide? So first thing what we'll do filtration. Because when we do filtration, this unreacted copper oxide will be removed. And then we have a salt solution. So from salt solution, what we can do, either we can use crystallization or evaporation, but there is no evaporation mentioned, so we'll use crystallization. So 1 and 2 are the process which we use to obtain this salt from the mixture. Then question 20, some reactions of element M are shown. So they give you some reactions for element M. First, what happened? Element M is burnt, so it will form oxide. Then this oxide is added to water, and then we have a solution, and then we add a blue litmus. So blue litmus goes red. If blue litmus goes red, it means this is acidic oxide or acidic substance. Like this oxide which was there is acidic. Because acidic oxide we mix, so it will make an acidic solution, and acidic solution turn blue litmus red. A blue paper, litmus paper, a blue indicator turned red, it gives an idea this is acidic oxide. And as I mentioned, that acidic oxides are, two possibilities are there. Acidic oxides are, or a non-metal oxide, basically two options are there. Non-metal oxide can be acidic or neutral. So this element should be a non-metal, because non-metal oxides can be acidic or neutral. So options which include metal, because iron is a metal, so it cannot be, because metal oxides are either basic or amphoteric, but not acidic. Magnesium oxide also it is wrong, because magnesium is a metal, so it should be a basic oxide, not an acidic. We are left with carbon and we are left with sulfur. So which oxide should be there? Carbon form two oxides. One is carbon monoxide, another one is carbon dioxide. Another one, sulfur form oxide, sulfur di and trioxide, but sulfur dioxide stable. So carbon monoxide, it is a neutral. It does not react with acid or alkali, so it cannot be carbon monoxide. Carbon dioxide turned lime water milky. So that is a test. So if we want to test carbon monoxide, we pass this through a lime water, it turned milky. But here what is happening? The oxide of the M, when it is added to acidified potassium manganate 7, it turned colorless. So this is not the presence of a carbon dioxide. This is actually a test for sulfur dioxide. That's how we test sulfur dioxide. When we bubble or pass through acidified potassium manganate, it turned from purple to colorless. So option D is the right answer, that this oxide should be a sulfur dioxide, not carbon. Because if it was a carbon dioxide, then it should turn lime water milky. Because test for carbon dioxide is lime water milky. Test for sulfur dioxide, acidified potassium manganate turned from purple to colorless. These are the first 20 questions from May-June 2021 paper. The next session will discuss more from this.